Okay, so this section is 1.5, postulates for points and lines in Euclidean geometry. Okay, so first thing is definition of postulates. So if you look that up on page 32, basically what a postulate is it's a statement that is assumed to be true. Okay, so I'll write that in for you. Statement assumed to be true. Okay, so it's something we assume is true. It hasn't been proven, scientifically proven by anybody, but it's something that we are going to believe that is true. Okay, now a theorem is a statement that's been proved. Okay, so the difference between a postulate is it's something we assume, and a theorem is something that's already been proved. Okay, a lot of times we use these interchangeably, and after the first couple chapters I don't even remember what they mean most of the time, but sometimes we'll have theorems, sometimes we'll have postulates, but we'll kind of get more into that when we get into doing proofs. Okay, so postulates and theorems will come up a lot, but you don't have to remember a ton about what the actual definition means. You have to remember more of what the postulate itself means or what the theorem itself means. Okay. And then they list Euclidean geometry again as a definition. We've written that a couple times already in this chapter, but if you want to look it back up on page 32, they do give you some more stuff on that, and they actually kind of talk about, if you're interested in the history of Euclidean geometry, they kind of talk about the guy that invented it, Euclid, and then a book he wrote about it, which is called Elements. So if you want to look at that on page 32, you can, but it won't be on, a test or anything like that. It's just kind of interesting. Okay, so we have our first postulate here. I think it's the first one anyway. So we have the point, line, plane postulate. Okay, so there's three different parts of this. There's unique line assumption, which you can find on page 32, number line assumption on 33, and then dimension assumption on 33 as well. Okay, so take some time, write each one of those postulates in. I know there'll be some questions about it on the assignment and in future stuff we're working on, so I would definitely go through and write those down from the book, and I'll talk through them with you and kind of give you some examples. Okay, so for the first part of it, point, line, plane postulate, part 1, unique line assumption. So it says through any 2 points there's exactly one line. If the 2 points are in a plane, then the line connecting them is in a plane. Okay, so the best way I can visualize this for you is we've got 2 points, okay, and they say those 2 points, there's exactly one line. So through these points there's only going to be one possible line. And it says if the 2 points are in a plane, so if these 2 points were on a flat surface, so say this is kind of our flat surface we're working with, so it's like a tabletop. So if you've got 2 points on a tabletop and there's a line going through those 2 points, then that line is also on the tabletop. Okay, so that's the only possible way it would work. So if you've got 2 points on your tabletop, a line that goes through those 2 points, and the points are on a plane, then that line's got to be on a plane. Okay, so that's what it's talking about, unique line assumption. Next one, number line assumption. I think this is the more simple one to kind of understand, but basically what it says is, it goes through some stuff, you can read it, but it basically says any line can be made into a number line. Okay, so I'll write that down. So this goes with B here. Any line can be made into a number line. Okay, and they go a little bit more in depth in their definition there. Make sure you have the real definition in your notes, but that's kind of a generalized version of what they're saying there. Okay, so then for part C, there's 3 parts of this. So for dimension assumption, first part, there's at least 2 points in a space, so in the entire space of the room or outside or wherever, there's at least going to be 2 points. Okay. The second one, 2, given a line and a plane, there's at least 1 point in the plane that is not on the line. Okay, so for part 2 of C, so this will be C part 2, what they're saying there, so it says given a line in the plane, so we've got a plane. we've got a line that's on that plane. So we got a tabletop, a line that's on that tabletop. What they're saying is there's at least one point in that plane that's not on the line. Okay, so they've got one point off here that's still on the tabletop, but it's not on that line. Okay, so like if this is our tabletop here, this is our line, there's maybe a point right here that would be on this tabletop still, but it's not on that line. Okay, that's what that part 2 of dimension assumption is saying. Okay, part 3 of the C says given a plane in space, so in the whole room, there's at least one point in space that is not in the plane. Okay, so what they're saying there is if you've got a plane or a flat surface like this, and it's in the entire room, so like a tabletop in the full room, there's at least one point in this room that wouldn't be on that flat surface. Okay, so if this is the flat surface tabletop, maybe we've got a point above the tabletop. Okay, so you got your flat tabletop here, maybe your point's underneath the table, or maybe your point's above the table. Okay, it's not on that flat surface, but it's still in this room. Okay, that's what they're saying for part 3 of that. So you've got some point that's in this room, but it's not necessarily on that flat surface plane, it's just in the room or in the space. Okay, those ones are kind of tricky, a lot going on with those. We'll use them some, but not so much that you need to worry too much. So this next one here, it says line intersection theorem, so two different lines intersect in at most one point. Okay, so what they mean there is if you've got two lines, so two straight lines, they are only crossing in one spot. You can't see my arms very well there, but they're only crossing in one spot. They'll never cross in more than one spot. And maybe you're thinking like a parabola. Well, if we kind of look here in the book, if I can get it up here, they kind of show that for a parabola there, but if we think about a parabola, that doesn't fit our definition of a line that we wrote down. I think it was in one of the first sections, where our definition of a line in Euclidean geometry was the shortest distance between 2 points. Well, if I've got a curve shape like this and I'm going from point P to point Q, the shortest distance would be that straight line there instead of arcing up and over. Okay, so when they're talking about this, basically your options for line intersection theorem are basically they cross in a spot like that, or they never cross at all, because it says, what's it say here? Two different lines intersect in at most one point. So they could also not cross at all, and we'll talk a little bit about that later. Okay, so now we're going to get into some examples here. So I don't know how much you covered this in your previous algebra classes where you're doing systems of equations, but basically our goal is to figure out where two lines cross. Okay, so if these were our two lines here that we had in a problem like this, we want to know what the point is where those cross each other. Okay, there's some different ways to do it. My favorite way is graphing because it's probably the easiest way, but I am going to show you these other ways just because they are in the book, and I don't want you to get confused why they're asking other stuff. But if you know how to graph lines and find out where they cross, that's all you really need to know. I'm going to show you the elimination stuff and the substitution stuff just so you have it in the back burner, and it's something that you may have touched on in algebra, may not have, just kind of depends on the year, but hopefully you kind of just follow along until we get to the graphing stuff. Okay, so for this one, it says find the coordinates of the intersection of the equations. Okay, so we got two equations there. We want to find out where they cross, just like that. So what you do for elimination is you want to eliminate or get rid of one of the variables. Okay, we do that by multiplying both equations by something. Okay, so my choice here is I'm going to try to get rid of this variable y. So I've got 2x plus 5y is equal to -4. 3x minus 2y is equal to 13. Okay, I'm going to try to get rid of the y. So what I want to do is I want to make the two y values opposites of each other. So what I'm going to do is I'm going to try to get these both to be 10s, where this one's going to be a -10 because of that subtraction sign, and this one's going to be a +10. Okay, I picked 10 because I can multiply these numbers both by something to get myself to 10. Okay, because if I take this top equation times 2, so if I take this whole top equation times 2, that will make this one 10y. Okay, so let me show you here. So if I do, it's kind of like distributive property where you do 2 times the 2x, 2 times the 5y, 2 times the negative 4. So if I do 2 times 2x, that's 4x. If I do 2 times 5y, that would be 10y. If I do 2 times negative 4, that would be negative 8. Okay, so all I did there, I didn't change what the equation means, I just changed what numbers are out front. If you went and simplified it all the way down to y equals mx plus b, slope-intercept form, it would look exactly the same as this one. Okay, I didn't change any of the values. Okay, so now my goal is to get this y to be a negative 10 so I can eliminate those because I'm looking for opposites. So to get a negative 10 for this y, I need to take my bottom equation and multiply the entire thing by 5. Okay, so if I took 5 times my 3x, using distributive property again, 5 times 3x would be 15x. 5 times subtract by 2y or negative 2y would either be minus 10y or plus negative 2y, and then you also want to take the 5 times the 13, which 5 times 13 would be 65, I believe. Okay, so then what we do to make these values go away or eliminate is we add these two equations together. Okay, so we want to make sure that our x's are lined up, our y's are lined up, and our equals are lined up. Okay, so we're going to do 4x plus 15x, which would be 19x. Now, our goal with elimination was to make these go away to get down to one variable. So if I do 10y plus a negative 10y, those would go away, so that's what would be eliminated. And then my equals on the other side, if I do negative 8 plus 65, that should give me 57. Okay, so now the whole reason why I did that was to make one of those variables go away, because I need to basically figure out what my x is that works and what my y is that works, but I have to do that one at a time. I can't try to attack an x and a y at the same time. I have to figure out what one variable is, then take that value and plug it in to figure out what the other variable is. Okay, so we've eliminated the y for now, and we're down to just an x. So now I've got 19x is equal to 57. Well, just like you do in algebra to solve this equation for x, to get rid of multiply by 19, you're going to divide by 19 on each side. So that goes away. So then you'll have x is equal to, and if you do 57 divided by 19, that comes out nicely to 3. So what that tells us is my x-coordinate, so I'm looking for an ordered pair here for my answer. My x-coordinate for my answer is 3. Now I just have to find the y-coordinate that goes with that. So if I'm looking for my y here, what I do is I take one of my original equations and plug my x value in. So I'm going to take my x and plug it into one of these equations up here. Now it doesn't matter which one you plug it into, either is fine. You'll get the same answer either way. I usually just pick the top one or whichever one looks easier, but it really doesn't matter. So if I take the top one there, I've got 2, and then instead of the x, I'm going to put in the 3. So 2 times 3 plus 5y is equal to negative 4. Okay, so again, now instead of having two variables to deal with, an x and a y, I plugged in for x, so now I just have a y to deal with. Okay, and then I solve this out just like an equation, so I'd simplify this here first. I'd go 2 times 3, get 6, plus 5y is equal to negative 4. And then to get the 5y by itself, I would subtract 6 from each side. So then I'd have 5y is equal to negative 10. And then to get rid of the 5, divide by 5. Sorry, I'm writing at an angle here. Divide by 5. So my y would equal negative 2. Okay, so my ordered pair that's going to be my answer here is my x is 3 and my y is negative 2. Okay, and if I took those two equations and I went and graphed those, that's exactly where those two lines would cross each other at the point 3, negative 2. Okay, and you could graph them to check them if you wanted to. Okay, so that's elimination, and like I said, I don't really care too much if you use that or if you just graph them. It's just kind of a way to do it if you don't have a graphing calculator. Okay, another way to do it if you don't have a graphing calculator is substitution. So how substitution works is you are replacing something. So like a substitute teacher is replacing the regular teacher. Okay, so what we're going to do here is we are going to substitute for one of the variables. So basically what you do is if you've got a variable by itself that equals the rest of the stuff, so in this case y would work for that because y is by itself equals the rest, and x would also work for that because x is by itself and equals the rest. What you can do is you can do some replacing or some substituting. So what I'm going to do here is I know that x is the value y minus 9. So my goal is the same as the other page, get it down to where I've got one variable so that I can solve it. Okay, so if I know my x is equal to y minus 9, I can take that y minus 9 and replace it for that x there, because that x is the same value as this x. So say that x was 10, well this x right here is also 10. Okay, so instead of having an x there, I'm going to replace it with y minus 9. Okay, so if I do that, replace that the x there with that chunk, I'll have y is equal to 2, and then instead of the x, I'm plugging in a y minus 9, and you want to make sure you have that in parentheses because x is being multiplied by 2, so everything that goes with that x is going to be multiplied by 2, so you'd put it in parentheses, and then plus 13. Okay, so all I did was I replaced the x value with what x is equal to. Okay, so now I'm left with all y's here, and I can solve this out. So what I would do here is I would start with distributive property. I would take 2 times y, 2 times negative 9, or minus 9. So I'd have y is equal to, 2 times y is 2y, 2 times negative 9, negative 18, plus 13. Then I could do some more simplifying from there. I could combine together my negative 18 and 13, get negative 5, so I've got y is equal to 2y, either minus 5 or plus a negative 5. Now when I've got variables on both sides, I want to try to get those variables on the same side. So my only option here is to try to move the 2y, because if I move this y that's by itself here, then I'm not going to have anything left. Okay, so my only option is to move the 2y. Okay, so to get rid of the 2y or put it on the same side as this y, I have to subtract 2y. Okay, so if I subtract 2y from each side, that goes away right there. Now over here, if I combine a y by itself is just like a 1y. So if I combine 1y and negative 2y, I'm left with negative y or a negative 1y. Writing at an angle again, aren't I? Okay, so then over here, the 2y went away, so I'm just left with equals negative 5. And then I've got one more step here to get the y by itself. I've got to divide by negative 1. Okay, so then that goes away, and I'll have y is equal to a positive 5. Okay, so now I'm halfway there because I know what my y is equal to. So if I've got my ordered pair here, I know the y of my ordered pair is equal to 5, and I just have to find what the x is now. So same as what we did before with the elimination, we're going to take that y value of 5 and plug it back up up top for a y value. Okay, in this one, the easiest way to find x is probably to plug into this bottom equation because it's already x equals something. You could plug into the top equation, you'd get the same answer, but I think it's easier to plug into the bottom one. So if I plug into the bottom one, I've got x is equal to, my y I now know is 5, so I can put a 5 in there, minus 9. Okay, well now to solve it for x, I just go x equals, well if I do 5 minus 9, it should give me negative 4. Okay, so now I've got both parts of my ordered pair, so my answer for this would be negative 4, 5. Okay, and again, if you took those two equations and graphed them, that's where those two lines would cross each other, at the point negative 4, 5. Okay, next we'll talk about parallel lines here, which I'm sure you've heard of parallel lines before. So parallel lines on page 35 says two coplanar lines, so they're on the same flat surface. M and N are called parallel lines, written, and they write it as M, and then it kind of looks like a picture of parallel lines, and then N. So they're saying those two lines are parallel if and only if they have no points in common or or they are identical. Okay, so basically what they're saying is if you've got two parallel lines like that, they're never going to share a point. Okay, so back before, all of the ones we did before are all going to cross somewhere, right? So they're all going to cross at an intersection, and those would not be parallel lines. So when we've got parallel lines, there's not a point that they both cross. Okay, so they're never going to cross each other, never meet, never touch, however you want to phrase that. Okay, so this next one here, it says, in the coordinate plane are the following lines parallel. Okay, so now I'm going to show you the graphing method. And like I said at the beginning of this lesson, I think that the graphing method is the easiest way to solve systems of equations. If you have a graphing calculator and you're comfortable using it, I think that that's your best bet. You can use those other methods. They just take, one, a lot more work, and two, it's probably easier to make mistakes because you have to do a lot more writing. Where with your graphing calculator, you can just kind of type this stuff in. Okay, so I've got my calculator here. So it says, in the coordinate plane are the following, are the following lines parallel? It's a question. Okay, so to be able to graph something and the directions are here, I want to go to the y equals button. So I push that, and if there's some stuff in there, I've got to clear it out. So I clear it, I arrow down to get the other one clear, and then I type in my equation. When I type in my equation, I don't have to type the y equals part in because it's already listed there. Okay, so I just start with 2x plus 3. So I'm going to go 2. My x button is the one that's directly under the mode button. So I push that, and then plus 3, and that's one equation plugged in. Then I arrow down to the second one, and I go 2x plus 5. Okay. Then to be able to see what the equations look like, see a graph of them, so we're on this step here, graph button, in the upper right corner is graph, so I push that, and it's going to graph both of those lines there. And as you can tell, looking at those two lines, you can tell that those lines are running parallel to each other. Now, if you weren't quite sure, one thing you can do is you can see if they cross each other or see if they intersect by pushing the second button, so a little blue button here, and that enables all of the blue words that are on your calculator. So I push the second button, and it'll show a little arrow there that it's kind of like a caps lock where it's, or like a shift. So I've got my second button on, and then I go to the trace button, which it says calculate above, so I'm calculating. And then I arrow down to intersect. And then it's going to ask you like first curve, second curve. It's just asking you for the lines. But in all the stuff that we're going to do, there's not going to be enough lines that it's going to make a difference. So I just tell people to press enter 3 times. So 1, 2, 3. And it's going to give us an error. Now the reason it gives us an error is because we were asking for the intersection of those two lines, and there is no intersection. Okay, if there was an intersection, so I'll show you something else here. So like say I typed in 3x plus 3, something like that, and I went to graph those. So those lines are different, and you can tell just kind of off the screen there that those lines are going to cross each other. Okay, so if I went through the process again of second, trace button, down to intersect, enter 3 times, that would tell me what my intersection is. Okay, so if there is an intersection, it will tell you what it is. If there's not, then it'll give you that error. So in this case, when they're asking if these lines are parallel to each other, we can say yes, they're parallel, and we could also tell that because they have the same slope. Okay, so if you've, might have been a while since you've covered that, but parallel lines always have the same slope. So you could do yes, parallel, and you could say same slope. Okay? But like I said, your calculator is a very nice tool to have on that because it can do all that work for you and you don't have to do all the longhand work. Now, if you were going to try to do this one on your calculator, what you would need to do is you would need to get both of these equations to y equals. Okay, so this one is already y equals. This one, to get it to y equals, so we've got x is equal to y minus 9. To get the y by itself, we'd have to add 9 to each side. So I'd have x plus 9 is equal to y. So I could take that equation there, and the top one there, we'll try it quick here. So I could take those two, so clear all this stuff out. I've got x plus 9 is equal to my y, and I've already got y equals there. And then my other one is 2x plus 13. So if I go and graph those, I should get this same spot where they cross each other. And it kind of looks like if we go -4 and then up 5, that looks like where it's going to cross. And you could check it by going second, trace button, down to intersect, and then enter 3 times. And it does tell us that it's at -4, 5, so we did that one correctly there, okay? But like I said, the calculator is the easiest way if you have one. If not, you might have to do it the longhand way. Okay, so that's all we've got for notes. So the book page assignment is page 35, 2 to 10 even, and then 11 through 16 all.